Okay, thank you for being here. Slides keep sliding anyway. Why on earth would anyone want to design another build tool? Don't we have enough already? I guess we are Scala people here, so we use SBT, right? How many people use SBT? Okay, Maven? A lot of people. Other build tools? Like?
Gradle.
Sorry?
Gradle.
Gradle, yes, okay, great tool. Maybe I dealt with this design problem because I want to build a build tool that it's not like the other ones. This is the first slide of a talk I gave a month ago in the Athens Scala meetup about YAB, and I considered using it also for Scala days, but my original proposal had this one as the title, so I stick to it. Another possible title could be Adventures in Build Land. A build tool is infrastructure, is like a compiler. We usually don't think about it, only when we complain about it. But generally we think it is there and it works. Trying to understand what it means to design such a tool is a very interesting procedure. At least that's what I have learned in the process. A few things about what I am going to talk to you about in this talk. Just at the beginning, a quick walkthrough of some build systems or tools that at least I use, the motivation behind this work, some key ideas that have been at the back of my head when I wanted to start this project, some key ideas that have passed along in the design and implementation process for the build tool that I am going to present to you. Design and semantics, okay, how it is designed after all, and what are some basic semantics. I'm not going to give a very detailed exposition about YAB right now, but I think I will give enough details for you to understand the motivation and the design decisions behind it. Some real-world examples from YAB itself, a roadmap, if I can say so, and some facts and personal impressions while working on this project. Now let's take a small tour. I think at the beginning it was Make. I still use Make when I want, for example, to write a paper because I like LaTeX and TeX, and usually I make a small Make file for this job. I've used Ant, I heavily use Maven, and Gradle sometimes. There are other tools in other languages and programming environments. Rake, for example, in Ruby land, Fake in F# land, SBT in Scala, I think is the de facto standard. And of course we have some new kids on the block, Hunchback and Bazel of Google, which is the open source version of their internal build project. I don't think I have got some inspiration from these tools, but basically I have approached the problem from my experience. Of course, I have used so many tools, so their vocabulary is in my mind, and I have used them so many times that maybe their design or semantics, implied or not, have taken part in the YAB's design process. Make is very simple. You just say your targets and then what you want to do. If you have some dependencies in the form of files, you also declare them. This is a very simple case of a Make file. Okay, you can do a lot of stuff with Make, and even create Make files that are very complicated. I just want to show some basic principles here. And how do you use Make? You just issue the command on the CLI with the target you want, and then it does the dependency management and tracking and decides what to do, what has changed, what has not, based on file timestamps, and then issues the commands that you have specified. Ant is an interesting case in Java land or JVM land. It takes the approach of an XML-based configuration, and it actually gives you a very expressive, let's say Turing complete, for the sake of this talk, language in the form of XML. It has a very simple interface. It gives you the ability to define any kind of action and implement it based on the given interfaces, and then you can use them from this XML-based configuration language. Ant is also target-based. You declare your targets and their dependencies, and inside each target you say what exactly you want this to do. mkdir and copy here are some actions that are defined in Java code, and they say which things they expect as input, and they document what things they create when they run. The running process of Ant is similar. You just say which goal to execute. Let's go to Maven. I think the cornerstone of Maven here is the dependency, declaration and management. You have this thing called the artifact, which is specified uniquely in, let's say, Maven namespace by giving a group ID, an artifact ID, and a version. And I think this is one of the two most important contributions of Maven, a standardized way to specify your dependency, a very standardized format. The other important thing that Maven has given us as legacy, I think, is Maven Central, the repository format and the repository itself. Maven can be extended using plugins. They are also declared like any other dependency in the form of this triplet, group ID, artifact ID, version ID. And of course, every plugin defines its own parameters, its own input that you can fill in with values, and they will be used during the running phase of the plugin. The CLI of Maven is very similar to the other stuff that we have seen previously. Now, Maven has a kind of rigid process, has some phases. These ones are from the default life cycle. It defines some life cycles like clean, default, and this is what gets called. It's predefined in Maven. It's fixed. Okay, so for example, if you define a plugin, you should expect it to run at one of these phases. I'm not an expert on Maven, so if you think something is incorrect or not exactly correct, please say so. SBT. This is a code of mine back in 2008. I think it was when Mark Hara was starting writing SBT, and I was an early adopter. And I actually was very enthusiastic about it. I even contributed sbt.bat, the executable for Windows, because I was on Windows back then. Actually, it does not count as an actual contribution because I never committed it to any repository. I just sent it via email. So maybe this kind of history has been lost. Now, I think SBT is the de facto standard build tool in Scala land. Its main characteristic, like Gradle, for example, is that it provides full Scala, a full-blown general-purpose language as its DSL. Of course, it has its API, but you can use Scala to do other stuff as well. It has plugins that can offer extra functionality, and I think lately the plugin functionality has been revamped and has been made easier and more user-friendly than ever. My concerns about SBT are concentrated in the last one. Is it simple? Is it easy? Because these things are not always the same. So let's go to my motivation dealing with another build tool. Actually, I had an itch to scratch. Back in the first Scala days, 2010, I had a similar talk. It was building without the closed world assumption. I was doing enterprise Java back then, and I had this project which had all kinds of enterprise artifacts, WAR files, web services, EJBs, everything. And I was told that we should use this shiny new IDE of the new version of the application server. And actually it didn't work. It didn't work. But I had to make it work. So out of frustration mainly, I hacked actually a script in Scala of about 100 or even 200 lines that did all the dependency management, build process, even deployment to the application server. And that was the main theme of my talk back then. So I'm into this. I'm interested in the build process. Actually, when I started developing YAB, I didn't make the connection with the Scala Days 2010 presentation. I usually use Maven. It works 80% of the time, and for the other 20%, you start Googling around, and sometimes you get frustrated. At least that is my story. But I am persistent, and I still use it. With SBT, everything seems great, but I personally don't feel at home yet. I don't know why. I have embraced it from the beginning, as you saw, but right now it doesn't feel that easy to me. And maybe it's because I have shifted my way of thinking about, for example, configuration, and I think configuration by programming is or should be considered harmful. I think this has been mentioned in a previous talk today about Twitter's code base. So with this prehistory, a previous talk and an existing but proprietary at the time a script that does some dependency management and handling the build process, I thought that the problem domain of a build tool is interesting. And actually, I told that at the beginning of this talk, a build tool is a kind of infrastructure that usually is taken for granted. So I wanted to get out of this mental process. I don't want to take it for granted. One other thing is that maybe I finished my other side projects and I had some spare time. Not actually, but anyway. I always need side projects just to keep my brain going, let's say, and have all the fun. So this was a perfect candidate. Now, let's go to some key ideas that guided me through the design process and that have gone through the implementation as well. I've been raised with object orientation, I mean professionally. Even at the university, I think we did Turbo Pascal at some time, some C++. I'm using Java since 1997, so it has been all about objects, data, and behavior together. And I don't like it anymore. Now I design I try at least with a clean separation of data and behavior. I don't want to mix them together if I don't have the exact reason why to do it. So objects, it has been debated elsewhere by experts, are not the answer to everything always. So driven by this data and behavior separation, I wanted a data-first approach. Gradle, SBT, these kind of tools, Rake, Fake, give you the full power of a general purpose language to define your build configuration. I didn't want that. I just wanted to start with plain old data and see how far I can go. And then, of course, you can't do anything with data alone. You have to execute at some point a function or something like that. I wanted that separated. Another key idea was to explore immutability all the way down. Now that I've told you that the configuration is plain old data, the next step is to tell you that I have represented the concrete or the abstract syntax tree of this configuration as an immutable tree. It's not very helpful all the ways, especially when you have to do post-processing and inject at some place in the tree functionality you don't know when you parse it. the first time. But actually, it pays off. Another key idea is to have a directed acyclic graph. I will say about it later, but I use the terminology of other build tools, like we have projects, sub-projects, or we have modules, as in Maven, and sub-modules. I want them to form a DAG, and whenever I see that there are cycles, the build process stops. So I kind of enforce a good engineering, software engineering principle, but coarse-grained. Within your module, within your sub-project, you can have cycles if you want, but you can only have a direct acyclic graph between your sub-modules. Now, one other key aspect is that I did not want to reinvent the wheel, okay, because I would be the first one who would not care about this project. It's not good to always reinvent the wheel. Of course, I told you that I want to think about this domain and this problem, but okay, maybe I wanted to start with some standards, some things that already exist and are useful, and then build from them. But I don't want, and I did not want to reinvent all the wheels. For example, Maven Central, I think it's an achievement. We have a central place which is standardized in its location, format, whatever, and we can always point to artifacts there and be sure that it's okay. Another thing is that I would like to reuse existing libraries via Maven coordinates. It's in the roadmap. Maybe at some point even reuse Maven plugins, but I'm not there yet. A basic idea is that I should try to keep it as simple as possible, but not simpler. I start with the data and behavior separation that I told you. Maybe it does not lead me that far, and maybe at some point I need to make it more expressive, provide a DSL that's not only data, it's something extra, it's behavior as well. This will be welcome, and it is at some points, but my main idea here is that I do not want to start with full expressiveness in the DSL, in the configuration of the build file. These are the points I explained earlier. Another thing, let's respect the developer a little bit more, I say. Don't throw them exceptions that they cannot understand. Be nice, give some advice if you have to give some advice. And YAB tries to do that. It has this notion of pluggable behavior, especially regarding advice, that it can tell you a few more things about your situation in the file system, if you like. Some ideas I was exploring and have been implemented in YAB is how to organize your project. Usually your build project is your repository and could be just one deployable unit, or it could be one or more deployable units, or it could be like Google where they have one big repository and all their code is below a root directory. I think YAB can, at its present form, can support all these styles. And innovation here is that we pay special attention to source code. Let's say you need a library at some point and you use it as a dependency, but then for some reason you need another version, but which has not been deployed yet. I mean, another version of, binary version of the library. What can you do? Not much, generally speaking. But with YAB, you can say, okay, bring me the repository of this library with its new version at the tag you wish, or the branch you wish, or at the commit point you wish, and I will use it as a dependency in its source form. Detection is not, change detection has been departed from the simple model of make. which is timestamp based, and we do hash-based change detection. We keep track of everything. When you define what you want to build and what you need in order to build it, we keep track of it. When it changes, we also keep track of it. When you say you want to build it again and the YAB can derive that there is no need to do that, it will not do it. So everything is cached aggressively, and computations are done lazily and only when needed. Another idea, managed execution of services. Services is the behavior. Think of it like a function. What do I mean by managed? Two things, basically. That I know they adhere to a given interface, so there is no vanilla code execution, and I also know exactly what they expect as input and what they produce as output. This is given as a specification to YAB. If you say that you build something, let's say I now have a compiler for the Scala language, it takes Scala files as input and produces class files as output. This is recorded by YAB, and it's a managed now service within YAB, and when, for example, the Scala compiler executes, YAB detects what the output is. This kind of behavior of managed services, especially regarding the input and output, can be helpful in order to have the reproducible builds, because actually it's a big problem. I think the Debian project have started to tackle it. The feature is very simple. You want to go to your code at version X 2 years back, and you want to produce your library, your binary file, or whatever, as if it was the originally produced library. The only way to do that is to define exactly what the input is into the build process, so it has to be managed. Okay, so these were some key ideas that I wanted them to go into YAB. How do I start? How do I design such a thing? In my Scala Days talk, I presented a tool that was very simple and easy to use, and it was based in the ideas of we define a build target and we define their components, their dependencies, and that's it, nothing else. For YAB, I tried to use metaphors. Sometimes a metaphor is easy to get us started. Maybe it cannot get us far, but maybe it can help us start. And that's all I needed. So maybe you could use this metaphor of using ingredients to cook some recipes and get out some dishes. The terminology is not altogether outside this domain, okay? Because you say, what is your recipe to compile? What is your recipe to do this? So I'm now going to present you the basic stuff regarding the domain model. At the low level, I have some ingredients. Make, for example, has files. I have other kind of ingredients too. They may be shell variables. Ingredients can be named. For example, when I implement the Scala compiler for YAB, a parameter, an ingredient for the Scala compiler, can be the Scala version that I should use in order to do the compilation. At the next level, we have recipes. They are descriptions of input and output. Just like you say, if you give me raw potatoes, I will give you fried potatoes. But I don't actually know how to do that. I just say that's the description of an input-output specification. For example, it's like when you read a cookbook. You read the recipe, you know what you need in order to execute the recipe, and you know what the outcome is, but there is no execution. You just read them. But you have the specification, and that's what recipes do. And ingredients and recipes are data. Let's go to behavior now. Adhering to my metaphor, the behavior is implemented by a cook. A cook knows how to cook recipes, right? Not all cooks know how to cook all recipes. What is a recipe? It can be the compilation of Scala files. A recipe can be the compilation of Java files. Please have in mind that YAB does not know anything about the idea of compilation. Okay? It only knows about input-output specification and some kind of behavior that knows how to execute the specification. So the compilation process is just an implementation detail. Okay. The previous entities are inside YAB as modeling principles. What do I use as an end user? I give orders. Okay. I go and say, give me fried potatoes. How? Based on the recipe of fried potatoes that I showed you earlier. Who is going to give me, to execute the order? A cook that I will say. So the end user specifies a recipe to execute, who will execute the recipe, and the ingredients. I'll show you examples. And the outcome is a dish that can be burned sometimes. I've got together here the basic entities, the basic ideas of the model. It's data everywhere, except for the cooks, which is behavior, and they are cleanly separated. Now, what do you do with your source code? How do you organize it? YAB imposes only one structural constraint. Whenever you want to build something with YAB, you have to place a configuration file in that folder. By convention, it is named yab.conf. It's a DSL that leverages currently the TypeSafe config library. I have found that it's very flexible, and during the 2 years that I've been sparingly developing YAB, it has been very helpful. So helpful that I have not met the need to create a specific parser for the DSL or something like that. You can organize, as I said, your projects the way you like. The only requirement is this. If you need something to be built by YAB, you place this configuration file. And this can go as deep as you want. Okay, so when YAB starts parsing your project, it tries to find a YAB.conf at the root folder. If it finds a YAB.conf at the root folder, then it understands it's a YAB-based project. Then it starts reading the subfolders recursively to find out if there are sub-projects that want to be built based on YAB. It is interesting to note that you can start your project with Maven or something else, and you can use it with YAB progressively. These things can coexist. The interesting feature that I mentioned earlier is about mounting external source code and bring it in your project as if it was your own source code. Now, an interesting thing that came out from the beginning is that, and I don't think I have seen it anywhere, is data provenance. Do we understand the meaning of provenance? It means where do things come from, the origin. Let me give you an example. I compute a value from a function. Okay, you get the value, but how was it made? It was made by giving an input to some function. If you don't track these dependencies, you don't have provenance. You do have provenance if you track all these dependencies. And YAB does exactly that. I thought at the beginning that it would be interesting to support data provenance in order to make it easier in errors for the end user, but it has proven to be a little more subtle than that. That's not the current form of the project by mistake, because I'm not on master right now, but anyway, it is a lot of months old, but it's enough to show you a few things. For example, we have the yabconf file at the root folder, and we have another subfolder there. That subfolder contains the yabconf file, and that's a structure. That's parsed by typesafe config. All you have to do is define your orders. Okay, so right now, if you follow the indentation, we have two orders. One is named compile, and the other is named jar. The compile order is of specific type, which means which cook and recipe combination I want to execute. So it says, call me Scalac, the Scala compiler, from the guy, the cook, who knows stuff about Scala. Another thing that this guy knows how to do is how to launch a Scala console. And all the other stuff are the ingredients that are needed in order to cook this recipe. The Scala version is defined in the recipe for the Scala compiler. Okay, here we just override it. It provides a default version, but we don't want to stick with it, and we override it. And then we give some dependencies in the form of other orders. Okay. Now, the reference here, the value of each order, is a reference to a sub-component, a sub-project within your file hierarchy. And the last part, after the double colon, is the order inside that component. So basically, what you do is this. You define your orders. You define the ingredients for the order, the dependencies to other orders in one place. And that's basically it. You don't need anything more. Because YAB, since everything is managed in there, YAB knows how to execute that stuff and how to wire stuff together in order to proceed. For example, let's take the jar order. What it says is, take me the output of the compilation, of the compile order, and produce a jar file. You don't have to specify what the output of this compilation is. Okay, you have done that once when you specified the recipe for compilation. YAB has enough knowledge in order to wire all these things together. And how it feels in the command line, you run it like this. You say, get me to this, to YAB VFS sub project, and execute me the compile order there. And it computes the dependencies, does a topological sorting, and starts from where it believes it should start, and does all the compilations needed or all the actions needed, because a recipe need not be a compilation process, okay? It can be something else. And if everything goes okay, it issues a check mark. Otherwise, it tells you about any error. That's another kind of order here, also a compilation. I'm giving it in order to show you that you can use Maven artifacts with respective coordinates as dependencies. So basically, with ingredients, you have everything that is defined in a recipe plus the dependencies. It could be a separate syntactic element. Maybe it could be better like this, but in its present form, it's inside, nested inside the ingredients. Roadmap, okay. I don't know if roadmap is the correct word here, but I'd like to write some docs. The code is documented, but the semantics are not, and I have to write that if it reaches a point for other people to use it. I'm actually doing an iteration now to introduce some service orientation, because At the beginning, I wanted to test the ideas, and some things were built in and hard-coded, and now I'm trying to make it more service-oriented. Of course, I'd like to open source it at some point. Why I have not done that yet is because I'm lazy and I don't like my code yet. So I think I'll be there sometime soon. Some facts and impressions. I really had fun designing this thing. I think it goes beyond existing practices. I have used immutability all the way. I have used data and behavior separation. I'm not throwing away more expressiveness. All that I am saying is that I'm starting low in requirements, and I'm trying to build up as I have more use cases. So in the end, if YAB has a DSL which is very expressive, I will be happy as well. I don't think it's not possible to reach that point, but I'm basically driven by use cases. Whenever I need to implement something that is not covered by the current model and semantics, I need to rethink. So I do some iteration. There is always a tension between keep it simple and keep it easy. Simple is usually about the designer, the architect. What are the principles and the semantics that you base your software on? Easy is usually about the end user. But actually, it's the burden of the designer, both to keep it simple and to make it easy. The end user just uses it. Okay, it's not the end user's fault if it's not easy or if it's not simple. So that's why designing is hard, because there's always a tension. You make a simple design that's easy for the end user. I think that we can go even further with these design choices that are inside YAB. If you think about it a little bit abstractly, there are a lot of things that can be described by this model. You have your immutable data that specify your recipe, what goes into the recipe and what goes out, what you provide and what you take out of the recipe. And then you have some kind of behavior that executes the recipe. Let me give you a simple example that could be surprising, but fits very well into the model. Let's say you want to install a specific package into 1,000 Debian servers. It's a recipe. Data and behavior separated. So it fits into the model. You can follow this Twitter handle for announcements and progress. And thank you very much. If we have time, do we have time for questions? Okay. And maybe I'll do you a demo. If we don't have for the demo now, you can come here later and I will show you the real thing. Yes?
Do you know about Nix?
Sorry?
Do you know about Nix Packet Manager?
Oh, yes.
So, I was concerned with what you are about. So, okay. I feel like you were inspired a lot by it, but couldn't you, I don't know, build an integration layer for Nix? Maybe have the same stuff?
When I learned about Nix, I had already started. YAB goes back to 2 years back. I started thinking about it in summer 2013, and I think the first commit was in September, and I built the MVP in November. MVP, I mean something that could bootstrap itself. Okay, so YAB can build itself now. It's quite complex in structure, but it can bootstrap itself. So yes, I like Nix, and maybe sometime I'll throw this and install something more appropriate. Now, yes. Today. Yes. It's not released yet, okay, unfortunately. I am struggling to make it releasable. So please follow the account for progress reports. But the goal is to release it because I want to use it. I mean, I have a problem using it in my own projects because it's unreleased. I can't do that to any client. So I want to release it.
Wouldn't it be worth just open sourcing it right away if people start looking and interacting?
If you look at have a look at my GitHub account, you'll see a lot of garbage for which I wasn't afraid to open source. For this, I don't know why. I haven't done it yet. Okay. I don't know why. Yeah, maybe tomorrow or one night I say, okay, what the heck, and I will open source it.
Because you might have contributors like presenting here, right?
Yes, I know. Yes, please.
So what kind of projects can you build right now? Can you build itself?
Yes, as I said, it can bootstrap itself. It's a 2.5 phase process, okay? Because I have at the beginning there is nothing, as you understand, from the Scala compiler, so you have to do it. So I have a big bash file which integrates everything together and calls the Scala compiler and builds YAB 0, the bootstrapping version. And then from that I use YAB to build itself in its full structure. So it can. Actually, it was one of the goals. As I said, I did the first commit in September 2013, and the MVP which I had as a goal was to build itself, and it was 2 months later. So yes, it can bootstrap itself. Now, the question was what kind of projects can we build? It's all about what kind of cooks I have implemented, okay? Because the unit of behavior, the service, the microservice, or you can call it whatever you like, is the cook, okay? A cook cooks recipes. I have implemented only the cooks I need for YAB itself. So, for example, for the Scala compilation thing, I delegate to Zinc right now. For Java, I use Javac because some parts, it's all implemented in Scala, by the way, with some Java classes. Any other question? Yes, please.
Will it support or does it support continuous execution or incremental compilation or both?
Okay, actually YAB does not know anything about compilation. It's only your build orchestrator. You say I have this module, this project here, and these are the source files and the artifacts I want to produce, and it delegates the creation of the artifacts to the cooks. So it doesn't know if your cook does compilation or something else.
Okay,
the current
for development process?
right now it's very incremental because I use an incremental compiler, Scala compiler, so it's very fast. If you make a change, it's okay. It's as fast as Zinc or SBD can go, something like that. Okay.
Yeah, do you have a prompt like in SBT?
Not yet. I would like to have. Yes, a shell. Yes,
okay,
yes.
You can use Zinc and you have incremental compilation, but if you have to do again, you have to start it again, and so on. And I think we burn a lot of time because SBT, you don't have to start this over and over again.
Correct. It's a matter of implementation, actually. For example, I can say that for sure for the Java compiler. I have two versions of the Java compiler. One that uses the class files of the Java compiler in process is another one that uses the Java compiler out of process. But it's a matter of implementation. And right now, in order to bootstrap YAB, I have only built the components that I need for itself. Another thing that I wanted to mention is that because I concentrate that much on data, and all the specifications are just data, not objects with behavior, I can transfer them over the wire. And right now, although YAB is implemented in Scala, there is no fundamental reason, at least from the principles of YAB, to implement something in Python, in Clojure, in your favorite language. Because all the things that need to be communicated are data with a very well-defined schema. So I think that's one of the things that I have won as an outcome with YAB. It can be polyglot fairly easily. Okay. Sorry, I didn't hear you very well.
Will you support any multi-model project, like a multi-tenant project?
Sorry, I didn't hear you.
Will you support like any project to support like categories or many sub-projects?
It does support sub-projects.
Yeah.
Okay, at any nesting level you wish. The only requirement for it to understand that it is a sub-project is to place this configuration file I showed you there. Okay, if it sees at the folder this configuration file, it understands that it's a sub-project. The meaning of a sub-project is that you define orders there and you can reference them from anywhere else in the project. Okay. I'd be glad to show you. I don't have time here now, but during the break to show you how it goes live.
One last question.
One last question. Yes, please.
So, if I understand it correctly, then the foundation is very well suited for distributed builds. So, compile it in one machine and then distribute the tests to 100 other machines.
True, you can do it, yes.
So,
You can do it.
all the data is serializable.
What you are saying right now is, I think, just a matter of engineering effort.
Yeah, you
Okay.
can implement it, but
Yes.
the design allows it. Okay.
The design allows it, yes. You have immutable data everywhere. The dependencies are well known. I can tell you a lot of things about GAP because at some point it has very naturally led me to understand the meaning and the necessity for dependent types, but that's for another talk. But the dependencies, let's say now, for your answer, for the answer to your question, that are statically known, and everything is immutable, and so you can do distributed computations very easily. Thanks a lot for hearing this.